The graph of y equals f of x is given below. Give the x coordinates of the points where the function is stationary. So we can see the gradient is 0 here, and here, and here. So that's B, E, and G. The function has oblique points of inflection. Well, it must have a point of inflection in between the maximum and the minimum. So I'm going to guess that that's at C. And it's also going to have one on this section between these two stationary points. So we'll say that that one is F. The function is strictly increasing. So strictly going upwards. Well, that happens between E and F. So it's always increasing along here. We can't say A and B because B is a turning point, so it wouldn't be strictly increasing there. F double dashed x is 0, so that must happen at the oblique points of inflection, so C and F. And also F double dashed is always 0 at a horizontal point of inflection. There's a slight confusion there. F double dashed x will be 0 at this point, but F double dashed x being equal to 0 doesn't say necessarily that this is a point of inflection. It could be a minimum or a maximum, but the fact we know it's a point of inflection tells us that F double dashed x will be 0. Now, just thinking about this, I'm just going to change something slightly here. It's no good me just saying E and F, that's actually just 2 points. So I should say that x is more than E and less than or equal to F. In actual fact, rather than F, I could say less than G, as long as we're not less than or equal to G, obviously, because G is where it goes 0 again. But if I go less than G, yep, it's always positive along there. And then the bit I missed just now was when x is greater than G, it seems that this is going to just keep going upwards.